Good day, grade 11. So the previous lesson we looked at exercise 1 to 6, solving Surd equations, and we did everything on the right hand side. So that means numbers 6, 7, 8, 9 and 10. You can, however, on your own time, if you want more exercise of this, you can go do number 1, 2, 3 and 4 and 5. Alright, so we are still by solving Surds and equations. We are now looking at the application of exponentials. So I'm just going to read through this, speed it up a little because we have lost a lot of time and we need to make up for that. So there are many real world applications that require exponents. For example, the exponentials are used to determine population growth, and they are also used in finance to calculate different types of interest. Alright, so yesterday or in the previous lesson I also told you that this example should be copied. Alright, so what is the this is a nice type of example type of question. Example type of question: a type of bacteria has a very high exponential growth rate at 80% every hour. If there are 10 bacteria, determine how many there will be in 5 hours, in 1 day and in 1 week. Alright, so the solution looks as follows. It will be the exponential formula. So this one is the final population is equal to initial population plus 1 plus growth percentage over the time periods in hours. Now, before we continue, I actually want to point out something to you, that this is actually an exponential formula, and which we used in money. So this is actually just being manipulated, and I'll show you in just a sec what it looks like actually. So as you can see, this is actually our interest of compound interest, our formula for the exponential formula of compound interest, which we use in financial maths, and therefore we're just going to use that formula and apply it to here. So what is the number of hours? It is 5 hours, so we simply just going to use substitution and do everything and then approximate the value. Alright, so if we type in, for example, like in 5 hours, what will it be? So in 5 hours we go to our calculator and then we have everything substituted, so it's going to be 10 multiplied by 1.8 to the power of 5. Okay, I would advise you to rather put that in bracket just for safety. It's not going to have it's not supposed to have an effect right here, but for safety put it in brackets, and then you will get an approximation of 1.88, 188.95, and if we were to round off to the closest number, it will be 189. Okay, step 2, in 1 day, so that means 24 hours. So now we're not only working with 1 hour anymore, with our 5 hours anymore, we're working with 24 hours. So our formula stays the same, however it's the time that changes the whole time. Alright, so our formula and then simple substitution just as well. We have already typed in the equation, so now we can just substitute the different times that is requested, and then we can fill in the answers like that. Alright, 168 hours. Your 168 hours is your week. Alright, that's how we get to 168. Sorry for that. Alright, so 168, that is your week. I think they ask here somewhere for a week. 5 hours, 1 day and 1 week. So that is the they ask for 5 hours and they ask for 1 day and in 1 week. And how do we get to the 1 week? The 1 week is calculated by multiplying the 24 times with 7 with 7. So we say 7 times 24, and that is how we get 168. So 168 is right there, and then we get our answer right there. Okay, so note this answer is given in scientific notation because it is a very big number. So scientific notation, this is a nice recap of grade 9 work where we write scientific notation. Only one place in front of the comma, and then all the places that follows we're going to write after the comma, and then we're going to write 10 to the power of how many places are still left in front of the comma. Okay. Alright, so work example number 17 is applications of exponential. The next question states a species of extremely rare deep water fish has a very long lifespan and rarely has offspring. If there are a total of 821 of this type of fish and their growth rate is 2% each month, how many will there be in half a year? What is the population of this in 10 years and in 100 years? So we have to calculate what will happen with population in how many will there be in half of a year, what will there be in 10 years, that is the second one, and in 100 years. Alright, now this is the, if you look at this formula, the formula what we're going to use here is, once again, it is what we know is our compound interest, but we're not working with interest here, however we're working with growth. So instead of using the letters P for starting amount and A for end amount, they use other words to describe or give meaning to the words. So you can go through that on your own time. And now we look at exercise 1.7, applications of exponentials. Ngobani, what is that? Ngobani invest 5,530 into account which pays out a lump sum at the end of 6 years. If he gets 96, or if he gets 9,622.20 cents at the end of the period, what compound interest rate did the bank offer him? Give your answer correct to 1 decimal. Now I'm quickly going to write this out and then we're going to continue. Alright, so give me a second to write this out. So it's quite simple. We're working with money here, so we can stick to the compound interest formula, the exponential formula that we're using here, and then all we have to do is have to substitute the values that is given to us. So our ending amount, what we end off with is that 99,622.2. all right, and then what we started out off with was that 5,530, and then our period is 6 years, so we would put that into our equation, and then the question says what compound interest, so we actually need to work out I, so it will be 1 plus I is the unknown or the variable, and then that is 6 years. Right, so how would we calculate this? First I would want to get rid of the 5,530, so I'm going to divide it on both sides by 5,230. right, so I get 5,530 on this side, and then I'm left here with only 1 plus I to the power of 6. Now I want to get rid of the 6, so what I'm going to do there is I'm going to multiply by 1/6 with the reciprocal of 6, so that means 1/6. So I'm going to multiply now with the 1/6, all right, and then 1/6, and then what that does is on the right hand side we are basically left with 1 plus I, and then on the right hand side we're going to get sorry, we need to work out that quickly, so let me just get the calculator. So all you have to do, you type in on your calculator, you can open a fraction, you type in let's start with the bracket, and then you type in your fraction, so it's 9,622.2 divided by 5,530, and then to the power of a fraction, which is 1/6, okay, and then you get that number. you can write that number out, and then it's going to be 1,09. So what I would suggest you is, I would suggest 9,67, and then you fill in that dots. What you do now with that answer is, I would suggest you to press the shift button now, so you can store this, and then you choose a symbol. Now you see here is your symbols, you can choose alpha. So it is on store now, so I'm just going to type in A. So now it means my answer is saved as A, and now I still need to determine I. So what I'm going to say is, I'm going to say 1,0967. That number continues, but now I'm bringing this one, I want to bring it over to the left hand side, and once I bring it over, it's going to become as a minus, and then my answer will be only having I on the right hand side. So therefore I can say now that, now I go to my calculator and I say alpha. Alright, I click the alpha, I type A minus 1 is equal to 0, so therefore I can say 0, where's that answer? 0,967, 0,0967, continuing like that. So if I were to, what did they ask you? Give answer correct to one decimal place. To one decimal place, so that would be 0, if I were to round up. So therefore the interest here would be 10%. So I will conclude, and to answer this question, what compound interest rate did the bank offer him? I would say, therefore we can say that if we round this off, the bank offered him an interest of or you can use approximation, or you can use the plus minus sign of approximation of 10%. Okay, so you can go check your answer by means of substitution. I'm not going to do number 2, so now you can do number 2 on your own. All right, and then number 3 you can do as well on your own time, and then we can look at number 4 quickly. A type of mold has a very high exponential growth rate of 40% every hour. If there are initially 45 individual mold cells in the population, determine how many there will be in 19 hours. Alright, so this is actually very applicable to our current situation of corona, the coronavirus spreading. So same formula is going to count, so I'm going to stick with my compound interest formula. So it's going to be A times P. A is equal to P 1 plus I to the power of n, and then we are simply going to substitute our values. So that means it's going to be P, if every hour there are initially 45 individuals, so that initial is at 45 mold cells in the population, determine how many will there be in 19 hours. So it's 1 plus, so we need to work out the I, and I will be 40 over 100, so that's 0.4 to the power of n, and then that will be our 19. So simple substitution, 40% every hour. If there are initially 45 mold cells in the population, determine how many. Right, so what we're going to do is just now work this out. So it's 45, 1 plus 0.4 to the power of 19. That you can type into your calculator, or you can type in that whole thing right there. If you type it into your calculator, it will be 45 times with 45 times with 1 plus 40 divided by 100 to the power of 19, and we can conclude that that will be 26,893. 26,893 mole cells will they be in 19 hours. All right, so here's a chapter summary. I want you to go through this on your own time. We recap on the natural number, the number system. We have our natural number starting at 1, now all numbers including the 0. Integers is your negatives as well as your positive. Rational numbers is any number that can be written as a fraction, where a and b as your denominator, your numerator and your denominator are integers, and never, your denominator must never be equal to 0. So it can also be written as decimal fractions, where it is terminating, or recurring decimal fractions. Then you have your irrational numbers, but cannot be written as a fraction, and you all know what kind of irrational numbers are also including the decimal numbers that neither terminate nor recur. And then we have our real numbers, including all rational and irrational numbers, that is the part of the whole number system. And then we have our non-real numbers and our imaginary numbers. So here's your definitions of some key definitions that you need to take note of. Is that a to the power of n is a times a up until n times, and then a to the power of 0 will always be equal to 1, but 0 to the power of 0 is undefined. And also a to the power of negative n is 1, can be written as a to the power of n, a as 1 over a to the power of n. Now remember, we always write, or we try as far as possible to write it with positive exponents. Alright, so laws of exponents, there's your basic laws. I think it's 1, 2, 3, 4, 5, 6. So that is your basic laws which you should recap on. And then we have rational exponents, how it can be written. Right. If we were to have a surd or something like that, we simply divide the outside thing through the exponent, and then we have our surd. So simplification of surds, we can multiply our surds. If the thing outside is the same, we can put them together, and we can also do the same for multiplication and also do the same for division. So exercise 1.8 is the end of chapter exercise. I would advise you to go through this on your own time. I'm not going to waste too much time on that. So simplify as far as possible. Simplification. This is fairly you're not supposed to have any struggles with this. If you have struggles, you can come see me. So I would advise you to do this on your own time over the course of the weekend. If there is any problems, please do come speak to me. All right, so our next chapter is the equations and inequalities. So what we can expect of this chapter will be as follows. All of those that is mentioned right there, every one of us we can read, so I don't want to waste too much time on that. And then equation and inequalities. Now I asked you guys to copy this terminology because it is very important, and then we're going to look at a quadratic equation and also the solving of quadratic equation using factorization. Alright, but first a little bit of revision. What is an expression, what is an equation, what is an inequality and a solution, and what is your roots? So I requested, or if I didn't request it yet, but I'm going to request you guys now to summarize this for me on your in your books, so that you have it in your books. Make sure you know it, make sure you understand it. Make sure you go through the zero product law. Anything times 0 will always be equal to 0. And then how to solve. This is recapping of grade 10, 9, 8 work. So this is simply to get you in the motion of solving inequalities and equations. So here's your method for solving a quadratic equation. You rewrite the equation in standard form. Ax squared plus bx plus c is equal to 0, and then you divide the entire equation by any common factor, that coefficients, to obtain the simpler equation of the form ax squared plus bx plus c is equal to 0, where a and b have no common factors. Right, so first step always is to see if there's any common factors. If you can take out the common factor, you simplify by doing so. Alright, so there's two solutions, and then it is your roots that will be determined like that. Always check the solution by answering back into the original equation by means of substitution. Alright, so there I also requested that you copy this example number 1. There's an explanation. We looked at this yesterday or the previous lesson, and then we have worked example number 1, 2 and 3, and then the revision. I actually want to get to the exercise. Here's some more examples for you to take note of if you do get lost or forgot your grade 10 work. Alright, so exercise 2.1, solution by factorization. Alright, solve the quadratic equations by factorizations. Answers may be left in Surd form where applicable. Alright, so what we are supposed to do here is as follows. I'm going to, let's start and do the exercise before we look at it as a group. Alright, so I would say let's start from number 14 until number 24, so that's about 10, and then I'm going to give you a minute or two to complete that. Okay, so number 14 to number 24, that will be our exercise that we're going to complete now. Thank you, grade 11. Please start immediately.